Hello everybody, this is Atharva with yet another integration and matrices problem. Today we will start with integration first and continue with matrices. So a few important problems in each of these topics and make ourselves much more efficient in them, such that we can make another good problem which involves both of these concepts to be used upon. Right, so let us start this. So the first problem is of x equals integral x power 4 plus x squared is what? Uh, x squared minus x plus 1 dx. Well, after initially first looking at this problem, you might think both the numerator as well as the denominator look quite ugly. One thing we will have done, which we previously know, is if we have any term that has integral numerator over denominator, we can write them as numerator equals lambda d by dx, that is the derivative of denominator, is du times denominator. So why we particularly do this is because now that I've got an n in terms of this term and this term, I can do, let us consider one integral x minus 1 by x squared plus 2x. Right? What we can do to this integral is, by using the method I've shown above, x minus 1, that's the numerator, will be equal to lambda times the denominator's derivative, that is 2x plus 2, 2, 2 plus u times the denominator itself, u times denominator itself, it will be x minus 1 equal to 2 lambda x plus 2 lambda plus new x squared plus 2 new x. So the interesting part is we're going to equate the x coefficient to these x coefficients and the constant to the constant coefficient. As there is no x squared, I can clearly state that nu is equal to 0, and with this given set information, lambda should be equal to minus 1. And lambda will be minus 1 by 2. Now you might wonder, why did I do this in the first place? So I did this for the first place because by doing this, I'm actually breaking down the numerator into two word parts. And once I break the integral into something like a plus b by c, I can just simply do this as integral e by c, integral e by c. But why derivate the integral as a coefficient for lambda and mu? Well, that's another good question. So that's because, let us consider we have polynomial f of x. So we will get something as lambda of f dash of x, that's the first derivative of it, plus mu f of x. Now, Let us actually put this into the main integral. We will get something like lambda integral of f dash of x is the derivative of x ln f of x plus mu times the integral f of x by f of x is nothing but nu. So it will be nu integral 1. So one extremely important formula is that integral f dash of x by f of x actually equals ln of modulus f of x. So using the similar formula for the first lambda integral, we will get the result quite directly, right? So why did I say this? Because the same application will be used for the next problem that we're about to solve. In this problem, when we solved it another method, that is the division theorem we've learned since quite a long time. So let me give a quick overview on what a division theorem really is, and it utilizes the same concept of actually breaking down the numerator into separate parts and using those separate parts to actually create more simplifiable different integrals to work upon. So let us use our division theorem. So what we normally do that here's the dividend, divisor, I'm sorry, and this is the dividend, this is the quotient, and this is just some number, a factor of divisor, and this is the remainder. So the theorem states that the divisor into the quotient plus the remainder will actually be equal to our dividend. So can you figure out what we're actually going for with this? So what I hope to do is, once I divide the integral we have, I hope for it to be quite a simplifiable one, and use the same technique to actually break the integral into divised into quotient over df of x we have plus the integral of remainder over f of x, such that we're actually again breaking down the same integral into two different halves. Continuing this strategy, let us do this to the main integral that we have. This one, right? So let us continue doing this and let us divide them properly. I hope you know how to actually divide a polynomial, right? It's quite similar to the way we divide numbers, but again, here is our x square, x, x square. So students, please remember this one thing. So as we actually divide, we're supposed to take the opposite side of what the result we've actually gotten. So this is our result here. So we're gonna do subtract. Well, this is quite an important thing because I earlier used to get confused on this and I've made quite a few mistakes with it. Oh yeah. So we get plus x cubed and the one above will remain unchanged. So I'm just going to be denoting it with u. U plus 1. And then x squared times x will yield me x cubed. X cubed minus x squared plus x. Now similarly, so let us subtract this. Let us add this back. Let this be a negative. Cancels out. And we're left with x squared minus x plus 1. And if we look at it properly, if I just again x squared plus x plus 1 here, it perfectly divides it, leaving me with remainder 0. Right? Yeah. So it's this into this plus 0. So can I just say the final thing we have using remainder here will be x power 4 plus x squared plus 1. It's nothing but the square of this, not exactly the square of it. Yeah, it's not the square of it because here is minus and here is plus. So it's going to be x squared minus x plus 1 into x squared plus x plus 1. Well, now let us put x power 4 plus x squared plus 1 in the form we've just gotten below. Right? So continuing this problem we get x power x squared minus x plus 1 into x squared minus x plus 1 into x squared plus x plus 1 whole divided by x squared minus x plus 1. And interestingly enough, these two cancel out each other. In the second, we will have integral of x squared plus integral of x plus integral of 1. That's nothing but x cubed by 3 plus x squared by 2 plus x plus the relationship constant of integration. This is our problem solved. And that's it. So it was quite an easy problem. In conclusion, we used two techniques here. First one will be the division formula we've already known since years. Second will be actually breaking down the integral. And the third one will be integrating using the formula integral of x power into x power n plus 1 by n plus. Thank you. Hope you had fun.